Hello students, welcome to this course. This course is called Advanced Information Technology. So the first unit under this course is going to be data processing, where we are going to look at various ways how data is processed within the computer system. So after this unit, will be able to explain conversion of data into information. Then we'll discuss data representation in the computer. Then we look at data processing cycle and data processing system. Then you also learn about the machine cycle. Then we'll be able to explain different types of memory and computer registers, explain computer bus, then discuss cache memory in detail. So before we go far, let us look at the major operations of a computer. So the first operation of a computer is it accepts data or instructions as input. So whatever you enter into the computer is looked at as data. Then will it stores data and instructions. Then it processes data as per the instructions, depending on what you want. Then it also controls all the operations inside the computer, and it gives results in form of output. So let us look at the functional units of a computer. So the computer has three functional units. That is the uh, arithmetic logic unit, the control unit, and the CPU. So once you enter data into the computer, we call that as input. So that data you enter into the computer is stored in the memory. So once data is stored in the memory, then the our arithmetic logic unit comes into play, which does the actual processing of data, and instructions are performed. So these operations performed by the arithmetic logic unit may include addition, subtraction, multiplication, division, logic, and comparison. So data transferred out from the storage unit may be accessed when required from the memory. So after the processing is done, then the output is made, but still this output can always be accessed whenever uh, further processing is needed. So we have the control unit. So the control unit, for it does the purpose of supervision. So it it acts like a supervisor, meaning that it oversees all the things that are done and are done properly. So the control unit determines the sequence in which computer programs and instructions are executed. Okay, so then the ALU, the arithmetic logic unit, and the control unit are jointly combined in a central processing unit, or what we call the CPU. So the CPU acts as the brain of a computer. So it makes all the important decisions within the computer system, including sorting or calculations, and also direct parts of the computer functions by activating and controlling the operations within the computer. So then let us look at transforming data into information, or data transformation. So as we have seen in the previous diagram, that is input into the computer, then the ALU performs different operations like addition, subtraction, division onto that data as instructions. Then at the end we see the output. So that process is what we call data transformation, or the process of converting or producing results from raw data that is input into the computer and converting it into meaningful information. So then we are also going to look at the data processing system. So all that process is also called the data processing system, as in the way of converting data into meaningful information. And it has three components, uh, of which is the control unit, the ALU, and the main memory. So the ALU are combined within the CPU, which acts as the brain of the computer. So in this case, uh, what the control unit does is it determines the sequence in which computer programs and instructions are executed. It acts as a supervisor. Then we have the ALU. So the arithmetic logic unit executes computer's commands. So these operations may include addition, subtraction, multiplication. Okay. So then we have the memory. So the memory stores data and commands that the CPU executes, and results that are mostly currently used by the computer. So mostly the memory, or in this case it is RAM, and it is volatile, meaning that data can be lost in case the system goes down. Okay, so that is the primary function of the computer. It holds data temporarily. So let us look at the data processing cycle. So as we have seen in the previous uh, diagrams, so once data uh, is input into the computer, or this process called the input stage, so that data is processed. Okay, so the processing uh, unit may include sorting, calculating of that data, summarizing, or maybe comparison. So after that data is processed, then it is stored. Okay, then it is stored into the memory, where it can be retrieved for further processing. Then after that data has been processed, then it can be output as meaningful information. So that is the data processing cycle. So let us look at memory. So computer memory is all about storage, but we have two kinds of memory. That is the primary memory, or RAM, which stores data temporarily, meaning that in case the computer system goes off, that data will be lost. Okay, so the primary memory is also known as the main memory, or simply the memory. Then we have the secondary memory, or the ROM, or read-only memory. So this stores data permanently. So every time you need to store data permanently, it is put in the ROM. So meaning that data will not be lost. Okay. So also ROM has different types. It can either be uh, external. Uh, for example, these external devices like hard disks, flash disks. So all those are types of secondary memory. So memory capacity defines how data, uh, the capacity of the memory to store the data in terms of quantity. Okay, so it can be described in kilobytes, megabytes, or MBs, also the GBs. Also, it goes ahead with other capacities like petabytes and others. So let us look at registers. So computer registers are small amount of very fast memory that is built into the CPU to speed up its operations by providing quick access to commonly used values. There are different types of registers which we are going to look at in the next slide. So these are some of categories of uh, registers. We have user accessible registers. So these are classified as data registers and address registers. Then we have uh, data registers which hold numeric values, for example, integers, floating point values. Then we have the address registers. So these hold addresses and are used by instructions that indirectly access the memory. Then we have the stack. These registers just are used to maintain the stack. Then we have conditional registers. These hold the truth values often used by the uh, computer to determine whether some instruction should or not be executed. Then we have the general purpose registers, which can store both data and addresses and can be easily accessed. There are other different categories, but let us look at this for now. So we have the bus. So whichever uh, every device that connects to a computer, whether internal or external, communicates through the bus or the computer bus. So there are different types of bus. We have the data bus, which carries data between different components of the computer. Then we have the address bus. The address bus just is used to select the route that has to be followed by the data bus transfer the data. Then we have the control bus, which decides whether the data should be written or read from the data bus. Then we have the extension bus. The expansion bus, which is used to connect the computer peripheral devices with the processor. So the cache memory. So the cache memory is also another type of RAM or random access memory that a computer microprocessor can access more quickly than it can access regular RAM. So cache memory has different levels with different functionalities. For example, level 1 cache, level 2 cache, there are different levels. So that's all for now in relation to data processing. Thank you.